Okay, in this video, we'll do some technical steps, but don't be scary, just some general introduction. Even though you may not have a computer or information technology background, you should be good with this video. Okay, we'll talk about a lot in this course, so we would like to introduce the concept of architecture. So for architecture, you may think about the construction, right? Traditionally in construction, architecture is both the process and the product of planning and the construction of buildings. So that's what you heard of architecture a lot. So in computer systems, an architecture is a set of, they're not physical, it is not a physical thing that describe the functionality, structure, and implementation of computer systems. The keyword here is that it is a set of rules and basically they describe how the different components, different functions of a computer system should be put together. So to be more specific to this course, architecture refers to the description of the main conceptual elements as well as the actual elements of a target system to each other and presuppose the design of the architecture. So we talk about two items here, two kinds of elements here. The conceptual element, so elements actually refers to the intended function, a piece of data and services. And actual element, meanwhile, refers to a technology building block or the difference. We also come to the definition of reference architecture. It refers to a generalized model that contains the richest elements and relations that are of relevance to the domain of Internet of Things. The key word here is that reference architecture is a generalized model. But, if we put this very simple, so for every vehicles on the street, right, it actually has a generalized model, right? Basically, you need to have a frame, you need to have a chassis, it needs to have 4 wheels, something like that. Basically, these are the generalized model of a vehicle. Okay? For the reference architecture for IoT application, so it will also contain some generalized component, which we will talk about in looking at solving a particular problem. The reference architecture is to be used as an aid to design and apply architecture. So this sentence describes the relationship between the reference architecture and slide. Reference architecture is a generalized model. So basically, it will highlight some common basic features, but for the specific scenarios, we need to develop and apply architecture that can be pinpointed to the specific problem. Basically it is usually the starting point of our solution. Having a new car, right? A new car to be used in the farm. Okay, so first of all, we'll first of all go to the reference model of vehicle, right? Basically, you need to have wheels, you need to have engine, you need to have the those kind of electrical. Since you are developing a vehicle to be used in the farm, so you may need to also add other features into the applied architecture of your car. For example, the car in the farm. So what we basically you would like to have larger wheels in that case because the food, so you need larger rows, and you may want to have a higher chassis, or you may also want to have some additional tools attached to your different farm tasks. So that's the relationship between the reference architecture and applied architecture. And for the reference architecture, we try to make it to provide the richest, let me go back to the original sentence, richest set of elements and relationship. So that's indicated here. So for the reference architecture, so you see there are many nodes here, MODE nodes. When we go to the applied architecture, First of all, remove some nodes we don't need. So you see they're removed. And very often we'll also add some other nodes so that we have the system solution. So when creating a model for the one person needs to have the overall objectives for the architecture as well as design principle. This architecture is useful, and we have some guidelines and principles. The problem domain establishes the foundation for the subsequent solutions. So it is common to pursue the architecture rule. So we have the problem domain, domain. So for the problem domain, it comes from the needs, basically what you want to solve, the problem based on your resources. Function domain, we will have a concept and base technologies. For example, we may have the Wi-Fi, Bluetooth as our base, which are important input into the solution domain. And then based on that, we'll create a system solution. The top level of the pyramid is problem domain. You will find out the requirement, the constraints. Yeah, easy to understand. For the solution domain, the actual system design that typically result in actual software and hardware components, as well as information. So that's for the solution. The design objectives and the principles are established, conceptual views are defined, and the required functions are defined, and where logical participation are described. For creating the reference architectures, there are two Sensei and IoT. Basically those are two projects. A common feature of these two projects is it is focusing on high-level approach. When we talk about horizontal, it needs to have the following networks and the related technologies from capabilities that enable services. Basically, when we develop IoT solutions, connectivity, communication is one part, right? We may use Wi-Fi, use Bluetooth, or maybe cellular communication. And for those are the communication issue. And for the capability or functionality of the device, you may have some software to present the information you want. In that case, these communication networks, the capabilities should be separated. The idea and the whole purpose is that we don't want these two items to be mixed. Otherwise, the benefit is that if the communication is not good or both functions, the capabilities can still be used. And also for the communication network, for example, originally you use Wi-Fi to connect your device, and then Wi-Fi is not reliable, then you may shift to using cellular, which just like your mobile phone, right? In that case, you just deal with the communication method or the cellular data, but the functionality is not affected at all. For example, you can still use to receive the emails. The feature of high-level horizontal is that there is a clear desire to define uniform interfaces towards the device that version. That's true. The idea is that so that the sensing and actuation capabilities can be used by different devices. So there's a clear desire to separate logic, highly application specific, that's common across a large set of applications. For example, you develop an function, have some common logic, or some common functions. Maybe you want to get the average number of the data, or want to get the minimum value of the data, common logic, common functions. These functions should be the functions specific app. For example, your app may want to attain some body weight and the temperature stuffs, and that's very specific for your app. So this logic or the functionality should be separate from the common functions. The idea here is actually so that if you later on you want to develop the current one, these sections is still available. Well, there may be a technical issue here. So, okay, so I don't know why there's a sign on my computer. So if you turn out to be not able to remaining items, it's a video, which is fine because next few slides we just listing some design principles, and there should be sufficient enough for you to understand them. But just now we mentioned that when dealing with the architecture, we need to know our objectives, and also we need to have some design principles, right? So our design objective of an IoT architecture should be to target a horizontal system of real-world centric services that are open service. So with this objective, there are several supporting design principles listed here. So we need to design for reuse of the deployed IoT application domain. So the keyword here is reuse. Basically, if you are in an industry or doing a business, times they may share share the same features. So basically, we would like to the idea is that we want part of this project can be directly applied to the next one, to the future ones. That will save your life, not save your life, save your time and effort for the IoT architecture. And also, it should provide open service-oriented capabilities and can be used for application development and execution by using a set of support services. So we have some detailed description down here. And also, it should design for different that hiding underlying complexities and heterogeneous to facilitate interoperability. So interoperability, the different components within a particular IoT system can work with each other. So in that case, we would to realize the complexity of heterogeneous. Basically, we want to actually this is also related to the Open API. Basically, we want the Open API to be communicate over the information, but for the details inside in information component, we want to hide them so that we don't cause complexity there. Design for stakeholder actors taking on different of providing and using services, business domains, and value chains. So we need to pay attention to stakeholders, and also design for ensuring trust, design for scalability, performance effectiveness, and design for evolvability, heterogeneity, and simplicity of integration, and design for simplicity of management. Models, service as software as a service here, and we also have other items as services. We'll talk about in the future. And also design for the life cycle support. Life cycle includes planning, development, deployment, and commission. These are the life cycle. These are the design principles for the architecture. So I didn't talk into details about it because for each of them, I provide an explanation of them to help you understand them. And because you are not an IT student, so I think that's a good level for you to learn, to know about in this class. So, and also many of these design principles, they are very straightforward. For example, management, that's straightforward, right? We don't want that the architecture and also the subsequent solution difficult to be managed. And there was some network issues during the middle of the video. If video is missing, so you should be able to read through the PowerPoint on those slides, especially for those for the design principles.